All right, so this next quiz is going to be on logarithmic differentiation and related rates. It's definitely one of the more difficult quizzes that you'll have this semester, but let's get right into it. So logarithmic differentiation is really just a new way of taking a derivative. It's all stuff that you kind of like technically already know, right? It's just using the properties of logarithms to take derivatives in new ways. It's kind of like most of the times it's an alternative to the quotient rule or the product rule, but sometimes you do actually need to use logarithmic differentiation. So really all you do, and I encourage you to, if you are familiar with this stuff already, work through the problem on your own and then unpause the video. But the idea is you take the natural log of both sides, and you're left with this. And one of the properties of logarithms is that multiplication inside of the logarithm is the same thing as addition outside of the logarithm. So this becomes ln of 5 minus 3x squared all to the 7th power plus ln of the square root of 6x squared plus 8x minus 12. So it just becomes the ln of that whole thing. So now another thing we can do is we can get rid of the square root, right? Because we can rewrite the square root as the 1/2 power. And then we can use the properties of logarithms to, if you have the whole thing that you're taking the log of is to a power, it can come down in front. So this 7 can come down in front of this ln. So we could bring the 7 down in front here, and then we can do the same thing with this 1/2. So it just comes down in front. And then now we can take the derivative of it. So the derivative of ln of f of x is a chain rule problem. So you could go through the chain rule, right? I'll do it once, where our outside function is ln x, our inside function is f of x. The derivative of ln x is 1 divided by x, and then the derivative of f of x is just f prime of x. So then you would do f prime of g of x times g prime of x. So our f prime is 1 over x, and then we would plug in f of x to that. So it would be 1 over f of x. And then we have to multiply by our g prime of x. Our g prime of x is f prime of x. So times f prime of x. So, and that simplifies to f prime of x over f of x. And you'll be doing a lot of just derivatives of logarithms in this unit. So one habit that you can kind of get into is if you're taking the derivative of a logarithm, so say we're taking the derivative of 7 ln of 5 minus 3x squared. We would keep the 7 out in front, but then the derivative of ln of 5 minus 3x squared is going to be that 5 minus 3x squared goes into the denominator, and then the derivative of that goes into the numerator. The derivative of 5 minus 3x squared, derivative of 5 is 0, derivative of negative 3x squared is just going to be negative 6x. So we have that. And then plus 1/2, and then this goes into the denominator, right? That 6x squared plus 8x minus 12. And then the derivative of that is going to be 12x plus 8. So then that would be our derivative for those two terms. And we can simplify this, right? So we could simplify this as just have a 2 out front, maybe something like this. And then we could rewrite this as like negative 42, right? Something like that, simplify it a little bit, why not? And then now the last thing we need to do is, because similarly to implicit differentiation, right, where we were trying to isolate our dy dx, also known as our f prime of x, we want to get it by itself so we can tell you exactly what the derivative is. And in this scenario, with pretty much all implicit differentiation, pretty much all logarithmic differentiation problems, we're going to need to multiply both sides by f of x or y, because then that will cancel out with the f of x in the denominator. So then we've got f prime of x equals then this whole thing. Actually, here, just this whole thing, and then we have to bracketed in because it's multiplied by the whole right side. So we're almost done. The only thing we need to do is we need to go back and we need to plug in our original function for f of x. So we just go back and literally copy paste the answer that, or just the original function that we were given. That becomes our new f of x. So this would be our answer times that. It'd be the whole thing times that, right? So that would be our final answer. You do not have to simplify that. Okay, now moving on to a very similar problem. So we're going to do the same thing here. We're going to take the ln of both sides. Ln y equals ln of sine of 3x plus x squared, all divided by 6 minus x to the fourth to the third power. Then, okay, so then ln y equals, and we pull this apart, so that's ln of sine of 3x plus x squared minus ln of 6 minus x to the fourth to the third power, because while multiplication within the logarithm is addition outside of it, division inside of the logarithm, right, is subtraction outside of it. So we would subtract those two. So then we'd say, all right, ln y equals, this term stays the same, right, because there's nothing, the whole thing isn't to an exponent, right? But this term, the whole thing is to the third power, so that becomes 3 ln of 6 minus x to the fourth. So now we're ready to take the derivative. This is going to be a chain rule, right? You could also think of it as the y goes into the denominator, and then what's the derivative of y? It's dy dx, right? So that goes into the numerator, and then similar thing here. That sine of 3x plus x squared goes into the denominator, and in the numerator we've got cosine times 3x plus x squared times a 3 plus 2x, because that's the derivative. That numerator is itself a chain rule. And if you feel uncomfortable with these jumps, by all means, take it slow, do the chain rule for each one of these. There's really no harm in just taking your time with this. And then over here, we've got a similar thing, right? So this 3 hangs out up front. This 6 minus x to the fourth goes into the denominator, and then the derivative of that goes into the numerator. Derivative of 6 minus x to the fourth is going to be a negative 4x to the third, so that can just simplify to negative 12x to the 3. So then this is what we're dealing with. So then we multiply both sides by y. So dy dx equals this stuff. And then instead of y, we just go back to our original function. And just copy paste it. So this would be our final answer. Okay, then the next one is going to be this. So this is an example. So right, for this first problem, we could have used the product rule. For this second problem, we could have used the quotient rule. But for this third problem, you can't use any rule, product, quotient, or chain rule. You have to use logarithmic differentiation. So when we go ahead and we do that, we get ln of f of x equals ln of 3x minus 7 to the 4x. Now, as we know, using the property of logarithms brings this down in front, this 4x down in front. So this becomes 4x times ln of 3x minus 7. Now, when we go to take the derivative of it, right, like exactly the same thing as the first problem, this becomes f prime of x divided by f of x equals, and then this is going to be a quotient rule problem, right, where our first term is going to be 4x and our second term is going to be ln of 3x minus 7. The derivative of 4x is just 4. And the derivative of ln 3x minus 7, that 3x minus 7 goes into the denominator, and then the derivative of it goes into the numerator, which is just 3. So then this becomes 4 ln of 3x minus 7 plus 12x divided by 3x minus 7. So then now we just multiply both sides by f of x. Those two cancel out, and we just get this whole side multiplied by f of x. We go back. This is our f of x. So we, oops. Just like this. And that's our final answer. All right, so then this is a little bit of a challenge problem. I don't know, not super hard, but like it doesn't have this last concept, right, with the whole bringing it down. But, you know, this is a good exercise. So basically, same thing as always, right? You take the ln of both sides. I'm just going to copy paste this time. That's a lot of writing. So then, when we go to break this apart, right, so it starts off kind of easy, right? All right, ln of square root of 5x plus 8, and that's going to be plus ln of the cube root of 1 minus 9 times cosine of 4x. And then it's going to be minus, and then in brackets, ln of secant x plus ln times, or ln of the fourth root of x squared plus 10x. And this whole second part is going to be bracketed, right? And that's important because that negative is going to be distributed to both of those terms. So really what ends up happening is we get ln of the square root of 5x plus 8 plus ln of the cube root of 1 minus 9 cosine of 4x. And then we've got minus ln secant x minus ln of the fourth root of x squared plus 10x. Okay, so then, derivative of ln y is going to be dy dx over y equals, and then we can rewrite this as to the 1/2. We can rewrite this as to the 1/3. Come on. And then we can rewrite this as to the 1/4. Come on. So that 1/2 gets brought down in front. That 1/3 gets brought down in front. And that 1/4 gets brought down in front. So then now we can go through, I'm sorry, this is still ln y. We haven't taken the derivative yet. But now we're going to go and take the derivative of each of these terms. So this is going to be 1/2 times, right? 5x plus 8 goes down in the denominator. Derivative of that is 5, goes up in the numerator. 1/3 times 1 minus 9 cosine of 4x goes down in the denominator. The derivative of that is going to be a positive 9 sine of 4x times the derivative of the inside. The derivative of 4x is 4. And again, if you feel uncomfortable with that, just break it down into a chain rule problem. That's the answer you'll get. Minus 1/4 times that x squared plus 10x goes down in the denominator. Derivative of that is 2x plus 10. So then we can simplify this, right? dy dx over y equals, that's going to become 5 over 2 times 5x plus 8 plus, we can simplify this. 9 times 4 is 36 sine of 4x divided by that 3 times 1 minus 9 cosine of 4x, minus, and this is 2x plus 10. We could factor a 2 out. I don't think you'd have to, but become 2 of x plus 5. Then 4 all times x squared plus 10x. So this would be a simplified form. So then now we can say, all right, multiply both sides by y. These two cancel out, so we're just multiplying the right side by y. So dy dx equals this whole thing and then we substitute in for y. We just copy paste our original y. And that would be our final answer. Okay, now moving on to related rates. I kind of want to make more videos about this, but this is one example of a related rates problem. This is for your regular triangle problems. All right, so a person is standing 15 feet away from a model rocket that is fired straight up at a rate of 10 feet per second. At what rate is the distance between the person and the rocket increasing 30 seconds after liftoff? So we got a few things here, and generally your strategy with these and just all triangle related rates problems in general is you want to have two triangles. One of them is general, so just kind of what's happening at any point in the problem, and then one of them is going to be at an instance in the problem. The instance, the giveaway that that you're talking about an instance is the word when. So there's no then here, but we're talking about 30 seconds after liftoff. That's a specific point in time, right? So that's kind of the dead giveaway that this is our instance. So we need to create a triangle without thinking about this instance, and then after that we'll create a different triangle with the consideration of the instance. So let's just fill in what we have. A person is standing 15 feet from a model rocket that is fired. So let's say this is the launch site. This is going to be the rocket. And then this is going to be the person. So the person is standing 15 feet away from the launch site. So A equals 15 feet. B will be the height of the rocket. We don't know how high this rocket is yet, but we do know it's going up at a rate of 10 feet per second. So we'll label that. As for dA dt, well, we know this person isn't moving, and we know the launch site sure isn't moving. So the distance, this 15 feet, is going to stay the same no matter what. So the rate of change of this is going to be 0 feet per second, so the dA dt is going to be 0 feet per second. This is going to be our hypotenuse, our c. This is going to be the distance from the person to the rocket. We don't know what c is. And we also don't know what dc dt is. dc dt is going to be the rate at which the distance between the person and the rocket is changing, which is what we're looking for, right? That's what it's asking us to find. So we'll put a star next to that. So now let's make our instance triangle, which we will do in red here. Or actually, first, let's take the derivative of this. So we're going to need to figure out dc dt, right? And we know pretty much everything about this. We're going to be able to find b in just a second here. So we know pretty much everything about this except for c and dc dt. So we want to involve dA dt and dB dt in our formula. So we can take the Pythagorean theorem. We can take the derivative of it, so 2a dA dt plus 2b dB dt equals 2c dc dt. And then we can go and we can make our instance triangle. So after you take the derivative, at this point, you can start thinking about your instance triangle. So same exact triangle. A is still 15 feet. Person is still not moving. So these two things stay the same. rocket is still going up at 10 feet per second, but we're talking about 30 seconds after liftoff. So if this rocket has been going up for 30 seconds and it's been going up at a rate of 10 feet per second, well then 30 seconds after liftoff, it's 300 feet in the air. So our B is 300 feet. And then we can use the Pythagorean theorem to figure this out, figure out the C value. So C equals this, A squared plus B squared equals C squared. So that's 15 squared plus 300 squared equals C squared. So that's 225 equals, what is that? 9 4 zeros. So 90,000. Plus equals C squared. So C equals the square root of 90,225. And on a quiz you'd be given something you could more easily work with, I would imagine. So 90,225, and we're still looking for dc dt, right? We don't know that yet, but that's okay because that's what we're trying to find. So now we have in our red triangle here, we have every point of information we could possibly need filled in, right? We know everything except dc dt, so we're going to solve this equation for dc dt. So let's go 2, and then a is 15, dA dt is 0, plus 2 times b is 300, times dB dt, which is 10, equals 2 times c is the square root of 90,225, times dc dt. And we want to solve for dc dt. So how can we do that? Well, kind of like implicit differentiation, right, where you're trying to solve for d dt. We can divide both sides by, well, so this is going to just cancel itself out, right, because 2 times 15 times 0 is just 0, right? So this is going to end up being 2 times 300 times 10 divided by 2 times the square root of 90,225. These two 2's can cancel out, and then this 10 is just going to tack another 0 onto here. So dc dt will equal 3,000 divided by the square root of 90,225, and then we have to provide units, and these will be in feet per second. For these types of problems, you can kind of just cheat and just steal the units of like all the legs of the triangle are going to have the same units, right? Because they're all just measuring the same thing. So you can kind of just steal the units of the rates of the other legs of the triangles and you'll be fine. So this is going to be our final answer.